Okay, let's dive right into this explainer and discover how mastering Cambridge O-level math is really just about selecting the precise tool from your mathematical toolkit. Welcome everyone to a very special deep dive strategy session. Today, we are adopting the mindset of the photographer. Think about what a master photographer does. They don't just randomly point their camera and shoot, hoping for the best. No, they find the perfect angle. They frame their subject to highlight the absolute most crucial evidence. And you know what? That is exactly what you need to do with your mathematics papers. In my years of analyzing these Cambridge exams, specifically the 0580 syllabus, I constantly see two distinct types of students taking on these challenges. Let's call them Alex and Sam. Now, Alex is an incredibly hard worker, but Alex completely overloads every single answer with raw mathematics facts, just a massive chaotic wall of numbers with zero structural analysis. And then we have Sam. Sam absolutely knows the math, but constantly rushes through the paper, completely missing the specific requirements of the command words. Today, we're going to fix both of those flawed approaches by looking at actual questions from Review Exercise 5, and I'm going to show you exactly how to frame your answers for maximum mark potential.
Rather than getting completely overwhelmed by a wall of equations, we are going to look at Review Exercise 5 as the ultimate diagnostic check for your core problem-solving skills. When you look at this quote, I really want you to internalize it. Passing these exams isn't about memorizing numbers, it's about recognizing patterns and applying the right tools. Alex tries to memorize everything, Sam tries to rush everything, and honestly, neither strategy works. If you look closely at how Cambridge math problems are actually graded by examiners, marks are awarded for the process just as much as the product. The evaluator wants to see your strategy in action. If you just write down an answer, even if it's 100% correct, but the command word explicitly stated show all you're working, you are going to lose out on easy marks. Today we're building a system to ensure you never ever leave those marks on the table again. We're going to break down these specific assessment objectives so you know exactly what the examiner is hunting for.
To do this, we'll build out 4 distinct toolkits today: the Algebra Toolkit, Mastering Quadratics, Boundaries and Proportions, and finally, Decoding Visual Sequences. Let's jump in.
Section 1. The Algebra Toolkit, the art of balancing.
The core goal here is isolation, whether you're solving for x or rearranging an equation to make p the focus. Take the first question. Instead of rushing it in your head like Sam might, you need to follow a clear structure. Now, you've probably heard of the Peel framework for essays: point, evidence, explanation, link. Well, top students use a modified Peel framework for mathematics too. Your point is identifying the command word. Your evidence is your line-by-line working. Your explanation is the algebraic justification, and your link is formatting the final answer exactly as requested. For a complex 4-mark question, the key isn't just arriving at the final number, it's demonstrating the entire process. It's about showing the examiner that you know exactly how to find a common denominator and cross-multiply. It's all about clear, line-by-line balancing. Now, before we continue, subscribe to our YouTube channel Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Making a variable like p the subject means we have to systematically move every single other term across the boundary of the equal sign. Think about how you'd start this. If your first instinct was to multiply both sides by the denominator, you hit the nail right on the head. From there, the strategy is incredibly straightforward, but you cannot skip steps. You group all your p terms on one side of the equation, you factor the p out into a bracket, and finally, you divide to isolate it completely. You are acting as the photographer here, taking a messy, intimidating fraction and zooming in until you have a precise, clean formula with p perfectly in focus.
When rearranging complex formulas, you have to watch out for common traps, especially mismanaging algebraic fractions. Here, the cross-multiplication tool is your absolute best friend. Let's do a quick find the flaw exercise in our heads. Imagine Alex expands a bracket with the negative sign outside, but forgets to flip the signs of the terms inside. Bam! That's a lost mark right there, entirely due to a lack of structural analysis. The professional strategy is to clearly identify your terms, expand your brackets with extreme care, and then logically move your variables to the left and your constants to the right. It's a strict adherence to balancing the equation step by step.
Section 2. Mastering Quadratics, Shaping the Equation.
This is where we see a massive difference in how students approach math. Quadratics aren't just one static thing, they are shapeshifters. Depending on the command word, you have to choose the exact right tool to mold the equation into the required form. Notice how the review exercise brilliantly illustrates 2 completely different approaches for the exact same type of math: factorization and the completed square form. Let's look at the command words carefully. If a question says by factorization and you use the quadratic formula instead, even if your final numbers are right, you might score 0 because you completely ignored the command word. You're simply looking to split that middle term to find two clean brackets.
Factorization is your go-to tool for finding quick, clean roots, but the completed square form, that is absolutely essential when the examiner demands an exact form answer. Notice the strategy. We take half of the x coefficient to build our square, and then we mathematically adjust the constant on the outside so it balances perfectly with our original equation. Listen closely. When a Cambridge question says, give your answers in a form which is exact, that is examiner code for leave it as a surd or a fraction. Under no circumstances should you write a rounded decimal. You keep that square root exactly where it is. That's how you frame the evidence correctly.
Applying these precise, step-by-step algebraic manipulations is exactly how you conquer simultaneous equations. Sam would try to rush this by just plugging in random numbers and hoping to guess the answer. We don't guess. We use a professional strategy. It's a structured, four-step process. You align the coefficients by multiplying the equations, you eliminate one variable entirely, you solve for the first, and then you substitute that value back in to find the second. It is methodical, it is logical, and if you follow the PEL framework, it leaves absolutely zero room for careless errors.
Section 3. Boundaries and relationships, inequalities and proportions. Now, before we dive into how to map geometric spaces, stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's get back to it.
Let's shift gears to see how variables relate to one another through spatial boundaries. What's really fascinating here is how the geometric space inside a shape, like a parallelogram, is actually defined by distinct algebraic inequalities. We are going into our interactive workshop mode right now. I want you to imagine a 60-second visual countdown timer right in front of you. This is Challenge 1, Data Scan. Take a quick scan of the visual boundaries. The region is given as y is less than x plus 2. Can you extract the core trend to visually find the other 3 boundaries before the clock runs out?
Time's up on the scan. By mapping out the 4 boundary lines of the shape, starting with the given y is less than x plus 2, we can deduce the remaining 3 hidden inequalities. Let's do Challenge 2, Find the Flaw. Imagine our overeager student Alex wrote this paragraph for his answer. Since the bottom line is flat, it's just the x-axis, so y is greater than 0. What is the massive flaw that is losing Alex marks? Well, the shape is a parallelogram. That means the bottom line is parallel to the top line. If the top line has a gradient of 1, the bottom line also has a gradient of 1. Since it passes through the origin, its equation is simply y equals x. The region is above this line, so the inequality is y is greater than x. Add in your vertical boundaries on the left and right, and you've perfectly, flawlessly mapped the geometric space.
Next, observe these proportion challenges side by side. These test your understanding of how variables scale together or push against each other. Think about how you would structure the absolute perfect mathematical response, where y is proportional to the square of x minus 1. You need to frame this answer so the examiner can't possibly dock you points.
Direct proportion means as one element grows, the other grows by a constant multiplier. Inverse proportion means one shrinks as the other expands. For direct proportion, the structural strategy is brilliant. Write the general equation with the constant k, substitute the given values to solve for k, and then use that specific formula to find your new target variable. It's the exact same reliable process for inverse proportion, just with a different formula structure, like putting the cube root of x in the denominator to account for the inverse relationship. Imagine a 30-second timer right now. If you were doing a speed writing challenge, could you write out that one perfect PEL paragraph showing those exact substitution steps? That's the level of fluency you want.
Section 4. Decoding visual sequences, translating dots to algebra.
For our final toolkit, we are going to tackle visual pattern recognition, which is a vital skill for complex mathematical problem solving. In this challenge, it isn't just about counting, it's about translating this visual geometry of expanding dots and lines into a reliable algebraic expression. Alex would try to keep drawing these patterns out forever on the exam paper, wasting precious time. Sam would just guess a formula in his head without checking it, risking an entirely incorrect answer. So, what is the professional approach? We use a systematic data table to frame our evidence. By simply charting the given visual data into a table for the first 3 patterns, the numerical gaps reveal the hidden algebraic rule for n. Let's look at the lines. The lines go 2, 7, 12. They're increasing by 5 each time. This constant difference tells us our algebraic expression starts with 5n.
But if we plug in n equals 1, 5 times 1 is 5. How do we get from 5 down to the actual number of lines in our first pattern, which is 2? We just subtract 3. So our golden undeniable algebraic expression is 5n minus 3. It's a beautiful logical progression.
Following these exact steps allows you to find the expression in terms of n, giving you the superpower to instantly calculate values for massive sequences, like finding out the stats for a massive 92-line pattern. This requires a beautifully simple two-step algebraic link. First, set your newly found line expression 5n minus 3 equal to 92. Solve that to find that n equals 19. That's your pattern number. Then take that pattern number and plug it right into your rule for the dots. That is exactly how you turn a confusing visual puzzle into a perfectly executed top-mark algebraic answer.
Section 5. Conclusion. Your mathematical toolkit.
The crucial point is that we just turned the daunting list of review questions into a highly structured toolkit ready for whatever math problem comes your way. We have a complete mathematics answering system now with 3 golden rules that guarantee top marks. Number 1, command word decoding. Number 2, Peel framework application for showing your evidence. And number 3, a time management matrix so you never rush like Sam. Keep these core strategies in mind. Always balance your algebra clearly, deliberately shape your quadratics, map your geometric boundaries, and chart your sequences. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
The only way to improve is to actually practice using these frameworks. So, looking at your own syllabus and past papers, which mathematical tool will you master next? Will you fall back into the trap of blindly memorizing numbers, or are you ready to become the photographer, deliberately applying the right tools and perfectly framing your answers? Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.